In this concept, the relationship what you have to talk is only about neighborhood, adjacency, and distance. So here first we'll talk about what is some basic relationship, nothing but understanding pixels in a digital image is crucial for various image processing tasks, including segmentation, feature extraction, and image analysis. For all, it is important. The section discusses the key concept of pixel neighborhood, see, adjacency, connectivity, regions, boundaries, and distance measure. It's basically a neighborhood of a pixel. Definition, pixel definition. A pixel P at coordinate x, y has neighboring pixel that can be based on their spatial arrangement. So what you are saying, each pixel at any coordinate x, y will have its neighboring pixel which can be classified based on the spatial arrangement. Spatial arrangement is nothing but from in the entire screen how it is and all the pixels how they are arranged. So there are two types of neighboring pixels. There is 4 neighbor and 8 neighbor. 4 neighbor is nothing but this is one pixel. So here up, left, right, and down. Whereas for 8 neighbors you will also have for what is the array? For 8 neighbors, you will also have like this, like this, like this, like this. Understood, right? So plus is your 4 neighbor, and for 8 neighbor, you will have all the even the plus and the cross. See, like this. So this won't be counted, right? So here are the 8 neighbors. This is the actual count. Understood, right? So here, see x minus 1. So basically, left and right is based on x values. So here x, this is x minus 1, and this is x plus 1. See, x is nothing but its middle. X minus 1 is what? It is on the left. X plus 1 it is in the sense what? It is on the right. The middle. Now y deals with up and down. If it is minus 1, so here minus 1 is above, it is plus 1, y plus 1, it is down. Understood, right? So now see here, if it is x minus 1, it is y minus 1, so it will represent here. If you know this much is enough, right? If x minus 1 and y plus 1, it will result to this. And this two, see, just this two, this two, this two, and this two will result to your remaining 4 neighbors, which are explained here. See, the 4 immediate horizontal and vertical neighbors of pixel P are. This set is denoted as n is nothing but n4 in the downside and in the bracket P. If I have to explain properly, n is like this, so here down 4 will come. Same way, if n is like this, down 8 will come and of P. N8 of P. Let's see. The 8 neighbors include the 4 neighbors plus the 4 diagonal neighbors. This set is noted like that. The neighborhood of a pixel refers to the set of neighboring pixels. So neighborhood of a pixel is what? This is all the neighborhood of a pixel which refers to a set of pixels and it is said to be closed if it is include the pixel itself. So that's all about neighboring. So here there are one diagram also which I can show you for normalcy, proper understanding. So here n 4 of p and 4 neighborings of pixel, we can simply read small destination. See, these all vertical neighbors. So all these set of pixels are called the 4 neighbors of p, denoted each pixel is unit distance. So them is each is unit distance. So for neighboring 8, for 8, see, we had found that's plus wala, right? Plus wala we had found. Remaining those plus is nothing but this is nd of p, and only diagonals. If you combine all the 4 is nothing but n8 of p. Understood? Right? See, don't get confused. nd, n4 and n8. So that's it, right? On this, then we'll move. And here in this PDF is just this much, but here we also have about what is adjacency, connectivity, region, and boundaries. Very simple things. See, adjacency is nothing but how pixels relate to each other based on their intensity values. There are 3 types of adjacency: 4, 8, and m. This m you can also write as what to say d also. It doesn't matter. 4 adjacent is nothing but 2 pixels p and q are 4 adjacent if q is in. Well, right. They are 4 adjacent if it is in this n4 of p here bracket. Same thing if it is in 8, if it q is in same thing 8. M adjacent is nothing but are m adjacent if two conditions in this, but q is or q is in see, q is either in this what to say up down, or q is either in this diagonal. Okay, that have values from the set V. So either it should be from this or this. That is M adjacency. Okay, if it is in both, then that is not M adjacency. That is 8 adjacency. Then connected component is nothing but a set of pixel S is said to be connected if there exists a path between any two pixel S. Well, think, see, set of pixels are S. A set of pixels are there. This is one set, this is one set. Between this, if there is a path, between it consisting entirely of pixels in S. So all the pixels, this path exists. So whatever the path is established, right? So all the pixels will be, how to say, there in that. Simple definition. What you have to write, set of pixels which are connected with, if there is path exists between any two pixels in S. So this is one set. Suppose this is one set. In that pixels are there. That pixel path should be, what to say, connected. That's it. Range is a region is nothing but a region R is defined as a connected set of pixels. So in set of pixels, two regions R of I and R of J are adjacent. Okay, two regions are there. We use R of I and R of J. This is nothing but you write R below it is this. Okay, same for J. If the union forms a connected set, okay, if you union R of I and R of J, it should form a connected like this. Either it should be like this or it is connected like this. That's all it's saying. A boundary is nothing but consists of pixel R that are adjacent to the pixel in the component of R. The boundary can be defined using different adjacencies. Boundary is nothing but this. Uh, this is one boundary. Plus symbols are one boundary. Force diagonals are one boundary. Just neighboring neighborhood is nothing but those boundaries. Then here distance is nothing but here you will have to go very down. So this page of 66. Let me just go to 71. 71. Oh, I should still go down. It will come somewhere over here. Some basic relations. This goes as neighborhood. Distance here. Distance C for pixel can give with coordinate x comma y, v comma u, and w comma z respectively. D is the distance function, or if d of p comma q is greater than 0, then d of p comma q is equals to 0 if p is equals to q. D of p comma q is equals to q comma p, and d of p comma s is less than equals to d of p comma q plus a. This something better. Okay? Just remember this one. Okay, remember this one, and this one. So four are there. I'll just say d e of p comma q is nothing but x minus u v y comma v. This is whole square. Actually a root. Or else you can simply say to the power 1 by 2. D4 of p comma is nothing but x minus mod of x minus u plus mod of y minus u. So it will just like this 4 4. Same ways for d of 8 is nothing but max of same what was there. My comma you have to put but max. And you just have to write all this 0, all are 1, then all are 2 like that. That's it. This completes this whole module.